Hello friends, let's continue our journey. We started with the fundamentals and then we moved to understanding how to do the testing, evaluation, and then see couple of use cases, and also how to do the deployment from small scale to large scale, hyperscale. So retrieval augmented generation is another important pillar in the implementation of agentic AI. So RAG gives a context, and it gives up it's a way of how to get rid of hallucination. So for retrieval augmented generation, we need to save data into the vector database. So the vector embeddings are created and indexed. Whenever any corpus for which the solution is built will have a large set of documents, and those documents are divided into small chunks, and those chunks are converted into vector embedding using vector embedding models like from Azure OpenAI Ada or Amazon Titan. And every model has different size of tokens, which maximum tokens which it can convert, take it and convert into embeddings of the different dimensions. So like OpenAI Ada supports more than 8,000 tokens, and it converts into a embedding of 1536 dimensions. So one thing to note is, while chunking in English language or similar languages, even subword tokenization is supported. So what happens is, like whenever you any solution you have a data, you pre-process the data, you make sure it is bias free and clean it, and then with the help of vector embedding models, we create the chunks, and those chunks metadata is saved into certain table, and it could be DynamoDB or Cosmos DB, and those chunkings are used put into a vector database. It could be a vector embedding in Postgres, or a Pinecone, which is a large scale vector database, or if it's an ontology kind of solution, we use a graph database. So once the data information is stored, when the user asks question, that question is also converted into vector embedding, and the vectors which are whose cosine similarity distance is least are retrieved and utilized to frame the answer. Right. So these solutions are used for asking questions related to the database in the system. Instead of building a HR solution, now with the help of RAG, question can be asked, and the agent can convert into SQL query and get you the output. Similarly, users can ask questions related to FAQ, like policy questions of the company, and those questions can be answered by the agent. So only take care as a admin is, like whenever policy changes or there is a change, the vector embeddings needs to be replaced with the new document. So in retrieval augmented generation, how the systems are built, let's understand, and the usage. So it's a two-step process. First is retrieval. So in case of retrieval, first we need to store data into the vector database, and then based on cosine similarity keyword search, we get the information and score it, and that information scoring is done by the agent, and that information is given to the language model along with the question asked by the user to synthesize the answer, which is based on the context and accurate, right? So in the chat, if we chat with large language models and it had been trained on certain date and time, and if it does not use RAG to retrieve the current information, it will hallucinate or it will give data based on which it was trained. So a vector database and use of RAG helps in grounding the information and provide the accurate information to the user. So how the cycle runs is the user asks the question and then the information is retrieved from the database, and that information is used to synthesize the output, and that is how the language model uses to build a story and respond to the user. So like in maths, we do XYZ plane, and then we see how the data points or lines are away from each other. Similarly, in the language there would be thousands of words, and how each word is how far is away from each other. So king and queen may be different gender, but based on royalty or the they would be close to each other. So cosine similarity measures the angle between vectors and gives the results based on which are the closest. Right. So in keyword search, matching is done based on keyword. So it will not consider the semantic similarity. So like if you say, I want to arrange a meeting, I want to have an appointment. So meeting, appointment has are synonyms, and both the sentences have same semantic similarity, right? So if the same question thing is asked in different ways, it should be able to retrieve and provide the same information from the vector database. So that is what vector embedding models are capable of doing it. So let's understand the first phase of the implementing RAG, that is ingestion and vectorization. So all the database which is information, documents, structured, unstructured data needs to be fed. It is retrieved, cleaned, and bias free, and then using the vector embedding models, they are the chunks of those documents are processed, and the vector embeddings are created, and then with the help of metadata, they are stored into the vector database. So while retrieving, one of the ways it is to make sure the context is right. When we retrieve it, along with retrieving the chunk which was matching, the neighboring chunks are also retrieved with the help of metadata information, right? So the second step after generating vector embedding is to store it in vector database and indexing the knowledge. Okay, so like in any RDBMS or any file format system, we do the indexing for the faster retrieval of the information. Right. The next stage is retrieve and synthesize. So for retrieval, whenever a user asks a question, that question is again converted into a vector embedding, and that vector embedding is given to the database, and it will find out the embeddings which are close to each based on cosine similarity. And that retrieved information, the top 5 or 10 answers are given to the agent, which can do the scoring of each of the answer, and that answer along with the scoring is given to the language model to synthesize the final output. So what database is right for you based on the solution what you are building it. So like Postgres with vector embedding. So where you want to use existing structured database RDBMS, and you along with that we have limited small size of data which needs to be stored into vector embedding and retrieved. So Postgres with vector extension is suitable for it. So otherwise, if there is a huge set of data spread globally, the Pinecone, which is fine-tuned and specialized for vector embeddings, can be used. It also supports partitioning. So based on which region accordingly it is used, the read replicas are created and they are kept in sync. Right, so when we use in partitioning based database, we need to consider CAP theorem, capability, availability, consistency, availability, and partitioning, and accordingly based on what parameters are important, we use those kinds of database. So in case of distributed database, some level of consistency gets sacrificed. But because of read replicas, the availability is faster. For ontology kinds of application, graph database can be used. Suppose like creating a mind map of the entire infrastructure of the company, which has routers, node, switches, all the machines, and the software installed on those machines. Similarly, with this kind of food, what drink I can have it, such solutions can be built using graph database. So as I mentioned, Postgres are suitable for structured data along with vector search. So relational data plus similarity is possible, and then a vector database for dedicated for large scale, we can use Pinecone, and they provide scale and speed. And volume is critical. So like for any data, we need to consider volume, velocity, and variety of data, and accordingly choose the database. As I mentioned, graph database are suitable for ontology kinds of applications. So in a global environment where we have different availability zones within the same region, or different zones across the regions, the vector database like Pinecone can be partitioned and sharded and kept into different lakes, and it will all have a master node, which will be the vector search engine, which can query into multiple partitions and retrieve the information. So volume, we need to understand based on the solution how much is the size of the data which needs to be handled, and along how much size it will over the period it will grow, and at what speed the data comes in, and we have to process some solution like which is real time for a stock market. Vector embedding generation has to be fast, storing that information into the database has to be in near real time, so the right information is given to the user, and variety of data, whether it's a structured, unstructured, semi-structured data. So all the parameters needs to be considered, and all this mapping can be managed with the help of metadata about all forms of data and sources. So while we are handling data, it is important that all the data is verified, it is secured, and privacy is maintained. Yeah. So it can be done along with other solutions for like privacy, Privacera, Ranger, Protegrity kind of solutions can be used. All the information which is converted into vector embeddings, they can be done stored in the form of encodings, and it can be decoded at the time of retrieval. And also the access controls can be provided, and like in case of cloud, all such data incoming can be put into public subnet, and from there it can be pulled into private subnet, and then you use it securely. So in the earlier solutions, for any HR system or like that, we had to build a solution, we had to wait for the period until the software is built. With the help of RAG, all the metadata about the database, all the information can be stored into vector embeddings, vector database, and when the question is asked, that information is retrieved out from the metadata. The select query is created, and it is run directly on the database, and the output is shared with the user. So RAG facilitates on faster access and easier to retrieve data without building the solutions. So retrieval augmentation can also be used for ontology. So it can be so similarly metadata about the vector database can be stored. The kind of ontology framework we are using, accordingly agent can create that cipher query language or to get the information from the knowledge graph. So it is a chatbot kind of application which customer support uses. So while the chat is happening with the user, it will, based on the question, parallelly a summary of those questions answer between them can be utilized to find the goal from the intent of discussion, and accordingly information can be retrieved from the RAG and shared with the and that will help the customer support to formulate the answer and also provide the right steps for troubleshooting. Similarly, in case of research or summarization, RAG would help to retrieve the information from the large size of data. Like suppose in case of life science or healthcare, if there is suddenly some pandemic kind of situation and need to find the antivirus in the set of the information, the nearest possible molecules which can be used for doing the research and finding the remedy makes the such solutions help it to make the research faster. So the four pillars of retrieval augmented generation, how it helps the intelligence at the enterprise level is like it makes it accurate. The information is retrieved from the documents. Those documents are time to time replaced with the newer versions, newer policies. It can be used at a large scale with the help of database like Pinecone and Graph database, and security can be done with the help of different tools and providing cloud solutions with the help of private subnets, public subnets, and with help of tools like Protegrity, Ranger, Privacera, and so on. So let's understand solve the quiz questions and see how much we have understood it. So the first question is in the retrieval augmented generation framework, what is the primary function of the retrieval component? Here are the four options, and here is the hint. So the next question, when addressing the variety challenge in the RAG data system, which type of data must the system be able to integrate? Here are the options, and here is the hint. Next question, which mathematical technique is commonly used to measure the similarity between two vector embeddings A and B in RAG system? Here are the options, and here is the hint. Next question, if an organization needs to implement RAG for a system characterized by highly connected data and complex ontologies, which tool is most appropriate? Here are the options, and here is the hint. Next question, what is the final step in the standard RAG implementation process before a user receives an answer? Here is the hint. Next question, how can RAG improve employee efficiency within an HR system? Here is the response options, and here are the hints. Next question, which challenge is specifically associated with the velocity of data in a RAG system? Here are the options, and here is the hint. Next question, what is the primary benefit of using a managed service like Pinecone in a large-scale RAG architecture? Here are the options, and here is the hint. Next question, in the context of data protection for RAG, what does access control entail? Here are the options, and here is the hint. Last question, PostgreSQL is a suitable tool for RAG when the user needs to perform both structured relational queries and vector similarity searches. Here is the hint. So one exercise which one can do is in Python there is a beautiful soup library. Using that library, you can try to scrape data from a website, and you can refer to the robot or text library file in the portal to know which pages can be scraped. That information you can process it, chunk it, and store into vector embedding database, and then you can when the user asks any question related to that website, the system will answer it. Thank you for your time, and we'll continue our journey and look forward to meeting you in the next sessions.